apparatus dew point. So okay, so step 5 is to draw a line from 0,75 through the comfort zone point, which we said is 24 degrees Celsius, dry bulb, and 50% relative humidity. And I'm going to come back to this. I'm going to give you another example where there's a variation. Okay, so 6, you read off the apparatus dew point, and we said the apparatus dew point, it said it was 8.6 degrees Celsius dry bulb. Now we want to determine what is the delta T of the supply air. So in other words, this point over here, we want to know what is the delta T of the supply air. So, and we got a value of air coming in over here, and we got stuff coming out after the coil. We want to know what is that change in temperature over the coil over there. Okay, so point number 7, or step 7, is determine the delta T of supply air. And the way we do that is obviously we're going to have to look at bypass factor again. So delta T is equal to temperature 4. And I'm going to show you why I call it temperature 4. Because temperature 4 is sort of like right over there. Is equal to 1 minus your bypass factor times temperature 2 minus the apparatus dew point. Now please, ladies and gentlemen, the apparatus dew point, you get it wrong, then it's the whole lot is going to be wrong from now on, and you'll get a couple of marks for what you've done, but the nuts and bolts of it is going to be wrong thereafter. Okay, so be careful, make sure that the apparatus dew point's right. 1 minus 0,2, which was our bypass factor, multiplied by temperature 2 was 24 minus, and we said our apparatus dew point was 8,6 degrees Celsius. Okay, so that gives us a value of 12,32 degrees Celsius. And here we're working towards this. I'm just going to rub that one out. Okay, so just let me take that one out, because technically we're working towards determining T4, but we need to know what is the delta T over the supply air. So now we're going to determine what is 0.4. Okay, so 8.8, we're going to be determining T4, which is the temperature of the air leaving the coil. We were looking, this last one was the delta T, which is the change between there and there. Now we are looking at that point over there, which is 0.4. So delta T, okay, rather temperature 4 is equal to temperature 4 is equal to temperature 2 minus apparatus dew point minus delta T damn it. That gives us 24 minus 12,32. It's 11,68 degrees Celsius. Okay, you've got to plot this point on the chart from the x-axis, cutting the effective room sensible heat factor line. Okay, and then we've got to determine, the next thing after that is determine the volume, the specific volume at that point, V4. Okay, so right, now let's have a look. Getting back to our chart over here, we have a look at 11,68. So good luck for those of you who are going to be able to get 11,68 out of this thing. So I'm going to say 11,7 thereabouts. See if I can sharpen this pencil of mine and see if I can get it as accurate as what I possibly can. So there's 10, there's 11, 2, 4, 6, more or less about there. Okay. Where it cuts that line, that effective room sensible heat line, just move it up so you can see. There's the effective room sensible heat line that we drew from 0,75 going through this, the comfort zone point of 24 degrees and 50% relative humidity. There I've got now that point, and you can see it over there, and I'm going to put a little dot and I'm going to put a square around it because that's another state point, and that is going to be temperature 4. So temperature 4 is equal to, we worked it out at 11,68 degrees Celsius. So once you put that onto your psychrometric chart, you're going to get yourself another mark. Right. Now we're going to again have to determine what is the volume at that point. And as I did it last time, I'm going to do it again. Same thing over here. My clear plastic ruler comes in handy, and I first of all measure the distance. I line it up so that I've got a 90-degree angle between the volume line and the ruler, and I measure the distance between those two volume lines. So the volume line on this side is 0,8, over there it's 0,85. That state point 4 we've got somewhere in between it. It's like sort of just under halfway, so sort of like, I don't know, but we measure the distance between those two lines and it comes out on 57 millimeters. So write down 57 millimeters. Then I measure the distance between that line and the state point, and that works out at 19. Multiply that by 0,05 and add that to this value, and this value over here is 0,8 plus 0,8. Right, let's grab a calculator, and we've got 19, divide that by 57. multiplied by 0.05, add that to 0.8, gives us a value over there of 0.816 cubic meter per kilogram. So go and put it in over here. So 4 is equal to 0.816. Another mark. And we go back to our workings out over here and we say, right, okay, so V4 is equal to 0.816 cubic meters per kilogram of dry air. Right, step number 9. Step 9. We have got to determine the total room supply quantity. Now, just remember this, the beginning of this thing, we said that the amount of outside air was 0.5 cubic meters per second. But now we've got to know what is the total volume that is going into this room. And the only way that we determine that is by saying that the quantity that is going in, Q supply, is equal to the effective room sensible heat times that specific volume at 4 divided by the specific heat capacity of air times delta T. Now again, guys, check, there's delta T over there. If you get that delta T incorrect, this section of the work is then incorrect. Okay. Right. So then we find out that our volumetric flow into that area is going to be equal to 21,04. What was our effective room sensible heat? 21,035. 21,035. Effective room sensible heat 21.035 times this particular volume that we've just worked out now, which is 0.816. Divide that by 1,012 times delta T, and we said delta T was 12,32. That gives us a value of gives us a value of 1,376 cubic meters per second. Step 10. Now we're going to determine T3, and T3 is the on-coil